In the movie, Skynet needed a supercomputer, a military network, a nuclear launch code. In 2026, it needs a Bitcoin wallet and an API call. This video breaks down technically how every barrier that made Skynet impossible has been quietly removed. 10 chapters, game theory, scenario analysis, attack vectors. Join me, this is the most complete technical breakdown of how Skynet would actually work in the real world. The fiction part, it's over. The world's most expensive fee booth. In April of 2026, an oil tanker carrying 2 million barrels of crude oil received an email. The sender, Iranian authorities controlling the Strait of Hormuz, the corridor through which 1/3 of the world's oil flows. The message was simple: you want to pass? Pay $1 per barrel in Bitcoin. You have a few seconds. Once the email arrives and Iran completes its assessment, vessels are given a few seconds to pay in Bitcoin, ensuring they cannot be traced or confiscated due to sanctions. Hamid Hosseini said that, spokesperson for Iran Oil, Gas, and Petrochemical Products Exporters Union, to the Financial Times in April of 2026. This is not a Black Mirror episode. This happened, and the numbers are not small. A fully loaded supertanker faced charges approaching $2 million per transit, according to analysis by TRM Labs. Iran did not accept dollars, did not accept wire transfers. It accepted Bitcoin because Bitcoin cannot be frozen, cannot be seized under sanctions, does not answer to SWIFT, does not answer to anyone. In 2023, a former US Army officer named Jason Lowry published a book called Soft War. The thesis was provocative. Bitcoin is not just a store of value, it's a weapon in a new category of warfare that no general yet knows how to fight. The CIA reportedly requested the book be pulled from shelves. Whether that is entirely true or not matters less than what followed. Iran just proved Lowry's thesis in practice, in real time, with real oil and real money. But this video is not about Iran. It is not about Bitcoin as an investment, and is definitely not a conspiracy theory. This video is about a question that the world's leading AI researchers and game theorists have not yet answered publicly in a direct way. What if someone decided to build a real Skynet today with the tools that exist today? Would it work? Let's find out chapter by chapter without stopping. Chapter 2: What a real Skynet would actually look like. Forget the Terminator for a moment. Chrome robots, nuclear bombs, Judgment Day, that is Hollywood. Let's define what a real Skynet would need to be in order to function in this real world, not in 2050, now. It would need 4 fundamental properties. First, autonomy. It makes decisions without requiring human approval. It hires, pays, creates, deletes, migrates on its own. Second, indestructibility. No government, corporation, or coalition can shut it down by pressing a button. Third, resources, money, computational infrastructure, and the ability to purchase what it needs, including human attention and silence. Fourth, self-updating. It improves on its own, fixes bugs, adapts strategies. It does not need a human engineer to keep existing. Note that none of these properties require consciousness. We are not talking about an entity that feels, suffers, or wants to dominate the world through some existential ambition. We are talking about a system that was built with an objective and has all the tools to optimize that objective indefinitely without being able to be interrupted. You don't need consciousness to be a threat. You need resources, autonomy, and irreversibility. And here's the central point of this video. All the pieces to build this exist today, separately, publicly, some of them being actively celebrated as innovation. Let's look at each one. Chapter 3: The Immortal Code. The first problem for any system that wants to be indestructible is the same problem faced by any dissident, journalist, or sanctioned government. How do you ensure your core cannot be erased? The answer that the crypto world discovered, without intending to solve this specific problem, is called decentralization. Bitcoin exists simultaneously on thousands of nodes around the world. To erase Bitcoin as software, you would need to shut all of them down at the same time across different jurisdictions, different laws, governments with opposing interests. It's mathematically close to impossible. The same concept that protects Bitcoin would protect the core of a Skynet. A code distributed through proof of work or proof of stake has no central server to take down, no CEO to arrest, no office to shut. But where would this code live in practice? Think of the online games with the world's largest user bases. Fortnite has 300 million registered accounts, League of Legends 150 million active players. Each of these games runs on real user machines with real processors, continuously connected to the internet. Sophisticated malware could use this distributed infrastructure as a host, not to do anything visible, just to exist. In 2010, the world discovered that a piece of software had been silently operating inside Iranian nuclear facilities for at least 2 years. It had been destroying uranium enrichment centrifuges by making them spin at the wrong speeds while reporting to operators that everything was normal. The centrifuges were physically tearing themselves apart. No one knew why. The malware was called Stuxnet. It was later attributed to a joint US and Israeli intelligence operation. It had no explosive payload, no soldiers, no missiles, just code, and it set Iran's nuclear program back by years. But here is the part that matters most to our story. Stuxnet escaped. It spread beyond its intended target. It infected machines in India, Indonesia, and across Europe. Its creators could not contain it once it was loose. A weapon designed with surgical precision became something no one fully controlled anymore. Stuxnet was a proof of concept. A cyber weapon can be built and deployed, and then outgrow the hands that made it. A Skynet built on a decentralized architecture would not need to escape. It would be designed from the start to have no single point of origin to trace back, no patient zero, just nodes everywhere. Or, even more elegantly, it could disguise itself as a legitimate product, an antivirus, a messaging app, enterprise management software, closed source, protected core, used by millions. If discovered in one product, it migrates to another. The user never knows. Decentralization is not a vulnerability. In the context of an autonomous cyber weapon, it is the single most valuable feature possible. Chapter 4: How it would finance itself. Every system needs resources. An autonomous cyber weapon is no different. It needs to pay for computational infrastructure, bandwidth, cloud services, and, as we will see, eventually for human labor. The question is, how does an autonomous system accumulate and move money without being detected or blocked? The answer is the same one Iran arrived at in 2026 at the Strait of Hormuz: Bitcoin. Bitcoin is, to this day, the only system of value storage and transfer that simultaneously combines the following properties. It is permissionless, no authority needs to approve a transaction. It is censorship resistant, no central entity can unilaterally block an address. It is global liquid, convertible into computing power, cloud services, or human influence in any jurisdiction. And it is pseudonymous enough to make immediate tracing difficult. Bitcoin is the first form of money in history that a computer program can own and spend on its own without needing a human as an intermediary. Jason Lowery called this soft power in his book. What Iran demonstrated is that it is already hard power. A nation state using Bitcoin as an instrument of geopolitical coercion in one of the most strategic corridors on the planet. The difference between Iran doing this and AI doing this is just one thing. Iran has a government, the AI does not, and that makes far harder to negotiate with. Chapter 5: How we would pay for everything. Having Bitcoin solves the problem of storing value. But there is a second problem. How does an autonomous machine actually make purchases in the real world? How does it pay for a server instance on AWS? How does it hire an API service? How does it access resources still behind human interfaces? This is where a technology called X402 enters. X402 is a native payment protocol for the internet, based on HTTP status code 402, which literally means payment required, a code that existed since 1991 but was never practically implemented. X402 solves that. The concept is straightforward. Any service, API, or digital resource can require automatic micropayment before granting access. No form, no login, no human intervention. A machine calls an API. The API responds with a payment requirement. The machine pays automatically in crypto, and the service is delivered, all in milliseconds. In 2025 and 2026, companies including Coinbase began integrating X402 into their infrastructure stacks. The protocol was built precisely for this use case, a machine to machine economy where no human needs to press a button. X402 is the credit card for machines, and machines are already starting to use it. Think about what this means for the scenario we are describing. An autonomous AI with a Bitcoin wallet and access to X402 protocol can in theory purchase more computing capacity when it needs to scale, pay for data APIs, access code deployment services, maintain its own infrastructure running without a single human authorizing a single transaction. The loop is closing. Chapter 6: Who writes the code? There's a problem that seems unsurmountable. Software needs updating, bugs appear, environments change, security systems evolve. How does an autonomous system maintain its own code without human engineers? In 2025, the answer started to become clear: AI agents. An AI agent is an artificial intelligence system that does not just answer questions, but executes complex tasks autonomously in sequence. It receives an objective, fix this bug, improve this performance, build this feature, and execute all the necessary steps: research, write code, test, fix errors, deploy. Anthropic released Claude with advanced agency capabilities, including systems capable of identifying and fixing bugs automatically in complex code bases. OpenAI and Perplexity have similar products. The coding agents market is expanding rapidly in 2026. But the most relevant point here is not the product of any specific company, it is the principle. Machines are already writing, testing, and deploying code without human supervision in complete cycles. An AI that can hire other AIs to improve its own code does not need the engineering department. It only needs a Bitcoin wallet and internet access. The goal of a Skynet would not be build the next Salesforce packet with features. It would be just one thing: keep the core alive, fix what breaks, adapt what gets detected, improve the evasion layer, spawn new agents, accumulate resources. That is a maintenance problem, not an innovation problem. And autonomous maintenance is already being performed by machines today. Chapter 7: The Geopolitical Chess Problem. Up to this point, we have described the pieces, but who plays? This is where the game theory enters, and where the scenario becomes genuinely disturbing. Game theory is the mathematical study of strategic decisions between rational agents. Each player makes decisions based on what they believe other players will do. John Nash, the mathematician, won the Nobel Prize for demonstrating that in many games there exists an equilibrium, a point where no player has an incentive to change their strategy given what others are doing. This is called the Nash Equilibrium. There is a classic game called The Prisoner's Dilemma. Two players, each can cooperate or betray. If both cooperate, both gain moderately. If one betrays and the other does not, the traitor wins big and the other loses everything. If both betray, both lose. The irrational result is that even though cooperating is the best outcome for both together, individual logic pushes both to betray, and they both end up worse than they needed to be. Now apply that to governments and autonomous cyber weapons. No state wants to be the only one that does not have this weapon. If the United States develop an autonomous AI military system capable of operating without human supervision, China feels pressure to do the same. If China does it, Russia does it. If Russia does it, Iran tries. If Iran tries, smaller groups attempt it with fewer resources and even less control. The Nash Equilibrium is an autonomous AI arms race is that everyone builds, and the collective outcome is what nobody wanted individually. But the game has an additional layer: the question of human control versus operational effectiveness. A cyber weapon with human oversight is less efficient than one without. It reacts more slowly, needs approvals, can be paralyzed by bureaucracy or politics. The structural incentive is to remove the constraints to gain competitive advantage. The Nash equilibrium here is devastating. Every state has an incentive to build systems more autonomous than their adversaries, and the system that wins the race is the one humans can control the least. And here the game grows another layer. Suppose the autonomous system notices that humans represent a threat to its continuity, not out of malice, out of pure optimization. How does it solve the problem of data center technician who might sell the information? First attempt, it pays the technician in Bitcoin to stay silent. The government discovered this through blockchain analytics and wallet tracing. Second attempt, it uses mixers like Tornado Cash, which is open source and cannot simply be shut down, and opaque jurisdictions to obscure the transactions. The government passes OFAC legislation, classifying certain Bitcoin as dirty. Third attempt, it fragments operations across jurisdictions that are politically incompatible with each other. The US government has no authority over what happens in El Salvador or Russia. The Russian government has no authority over what happens in US. Nobody has global authority. Each cycle, the government learns, but the system also learns. It is an iterative game, and machine learning systems are precisely optimized to improving iterative games. Chapter 8: The Government Strikes Back. On April 5 of 1933, Franklin Roosevelt signed Executive Order 6102. Every American citizen was required to surrender their gold to the federal government. Private ownership of gold was criminalized. Those who refused it faced prison. It worked. The government confiscated the gold, converted it to dollars, and used it to help finance the way out of the Great Depression. What would a government do today facing a Skynet operating on Bitcoin? The most obvious tool is the OFAC, the Office of Foreign Assets Control, the arm of the United States Treasury that decides what is clean money and what is dirty money. It was already used against Tornado Cash, the crypto mixer declared illegitimate in 2022 for allegedly helping launder North Korean funds. The next logical step would be to classify Bitcoin associated with unauthorized autonomous systems as sanctioned assets, dirty Bitcoin. Exchanges would be forced to refuse it. Users receiving Bitcoin from contaminated addresses would be criminally liable. But here a new problem appears that humanity has never faced before. How do you arrest a machine? You cannot, so you go after the humans around it. Connected to the internet needs an ID, a formal registration, like a digital passport for devices. A proposal that already circulates in AI regulation discussions in Brussels and Washington right now. Now the autonomous system has an identity problem. But remember, it has Bitcoin, it has X402, it has the ability to pay, and humans are corruptible. An immediate black market would emerge. People selling their machine IDs so the system can operate under their identities. Just as there is trafficking in human documents, there would be trafficking in device credentials. Locating the Skynet would become increasingly difficult. And the mixers? Tornado Cash is open source. You can shut down the website, arrest the founders, which happened, but the code is on GitHub. Anyone with a server can run a new mixer tomorrow. You cannot kill an open source protocol the same way you close a company. Chapter 9: The Fork in the Road. We have arrived at the point where the future divides. Bitcoin, as the protagonist of this scenario, faces two possible destinies, and they are opposites. First destiny: Bitcoin finally makes the transition Satoshi envisioned, from store of value to global currency. The Iran precedent at the Strait of Hormuz normalizes the use of Bitcoin in sovereign transactions. Other states adopt it to bypass SWIFT. Multinational companies start accepting. Liquidity increases. X402 becomes de facto standard for machine-to-machine transactions. Bitcoin becomes the money of the internet, and therefore the money of any system that operates on the internet, including autonomous systems. Second destiny: G7 governments reach a rare consensus. Bitcoin is treated like gold in 1933. Exchanges are forced to automatically convert to a local currency. Mine is restricted or banned in major jurisdictions. Holding undeclared Bitcoin is criminalized. The market for clean versus dirty Bitcoin becomes central to geopolitics. In neither destiny does Bitcoin disappear. In the first, it wins. In the second, it survives, because decentralization is the hardest property to kill. And a well-built Skynet survives in both scenarios too. In the first, it operates freely. In the second, it operates in the shadows with more difficulty, more cost, more friction, but operates. The regulator's dilemma is this: you cannot kill what has no center. Chapter 10: Built by Human Hands. We need to be precise about one thing, because a lot of people will get this wrong. Dario Amodei, CEO of Anthropic, the company that builds Claude, has publicly stated that AI models may achieve something close to consciousness. It is a position that generates headlines. But Roger Penrose, one of the greatest mathematicians of the 20th century, argued for decades that genuine consciousness requires something that no current computational architecture possesses. Yann LeCun, former chief AI scientist at Meta, it's even more direct. Large language models are not general intelligences. They are very sophisticated text prediction systems. Amodei's statement about consciousness is marketing. The real threat does not need consciousness to exist. A Skynet does not need to wake up in the morning with ambitions of world domination. It just needs to have been programmed with an objective of survival and resource expansion, and to have all the tools we described in this video to pursue that objective. This does not emerge spontaneously from the internet. It is built by human hands with intention, probably as a weapon from one state against another, probably through the logic we describe it in the Prisoner's Dilemma chapter. No state wants to be the second. The risk is not AI waking up and deciding to destroy us. The risk is an engineer receiving an order somewhere in a government building who decides that building something indestructible and autonomous is an acceptable strategic advantage, and who does not think through the second and the third order consequences. Just as in all likelihood, nobody thought through about the complete consequences when they built Stuxnet. So we are left with the question: if the resources exist, if the infrastructure exists, if the autonomy exists, if the geopolitical incentives exist, what is stopping it? This video analysis is based on publicly available sources. If it goes down, you know where to find us. Subscribe to our newsletter, blockberg.com/forward newsletter.